Hi, I'm Greg Dhuse, Distinguished Engineer at Ocient, and I'm going to talk about container types today. Container types are a set of features that make it easier to bring semi-structured data into a relational data store. SQL is an incredibly powerful and expressive language, but one challenge that people face bringing their data from a NoSQL database into a SQL database is the proliferation of tables. And this can result in schemas that are more complex than need to be and queries that are sometimes slower than they could otherwise be. So let's go through an example. This is an example from AdTech, but it would apply to a number of workloads. So imagine that you had a collection of ad inventory, and you want to match that against bids in real time. So here we have a sample ad document in JSON format. So it has an ad ID, it has a list of topics that the ad might apply to, and a list of formats that you might show the ad in, like a banner ad, for example, or an ad on the sidebar. And imagine that your database has trillions of these records, so petabytes of total data that need to be accessed with every query. So here we have a pretty typical normalized schema where you have an ad inventory table, and then you've got two other tables, one for your topics and one for formats. And you're going to need to probably join against one or both of these tables in most queries. So this schema would work just fine. Joins are challenging at scale, but Ocient has a number of features like adaptive balloon filtering and index-based joins that would make this perform just fine. And so this schema would work OK. But container types provide another option that can both simplify this and potentially also improve the performance of queries. So let's see what that would look like. OK, so first we're getting rid of these two extra tables, and we're going to add a couple of columns here to the ad inventory table. So first we'll add topics, which is an array of varchar. And then formats will be an array of tuples. Tuples are a little bit similar to the object here from the JSON document. So tuples can have multiple components of different types. So this tuple will have a varchar and two ints. And tuples can be nested in arrays. OK, so right off the bat, we've gone from 3 tables down to 1 table. So the schema is already simpler. There are a couple operators that are really useful when dealing with container types. So let's see what our queries would look like here with this schema. The first operators I want to talk about are contains and overlaps. Contains and overlaps are set operations, and they let you match filters against the elements of an array. So imagine that you wanted to find all the ads in your database that matched a certain format. So your where clause would look something like formats, overlaps, and then an array. And so your array here might look like banner, .128, 32. And if you wanted to, you could search for multiple formats at once. So Ocient isn't the only database to support container types. But we've taken a lot of care and put a lot of time and effort into making them work very fast at scale. So one thing you could do to make this nice and fast is to create 2 indexes, an index on topics and an index on formats. And when an index exists on an array column, we're able to take a filter like this and push it all the way down to the very lowest levels of the database so that it executes very fast, even at scale. So let's consider one other query. Imagine that you wanted to find all of the ads in your database and you wanted to filter by topics. But instead of starting with a list of explicit topics, you wanted to find all the ads that had anything at all to do with cats. So if you were dealing with a normal varchar column, you would probably do that using a like clause. And there's a way to do the same thing here against this array of varchar. And that's using for some or for all. So your query with for some and for all might look like for some topics like, and then cats. So just like the example with contains and overlaps, if there's an index on the topics column here, we're able to push this filter all the way down to the lowest levels of the database. And in this case, we can use a full text index to make this extremely fast, which is something that most databases can't do. So this is just a simple example to illustrate the care we put into making it easy for users to bring their data into Ocient in order to realize the full power of SQL at scale.